Okay, today we're going to be solving simultaneous equations using matrices. The first thing we have is we have two linear equations where it's in the form ax plus by equals to c. So we always want to have an equation like this, which we have two of them. And the first thing we're going to do is we're going to create two matrices. A matrix which contains the coefficients of all our variables, and a matrix that contains the solutions to those equations. So for the first matrix, I'm going to draw a simple 2 by 2 matrix. And it's going to contain the coefficients of x and y in that order inside of this 2 by 2 matrix. So I have 3, -1, 4, -1, because this is 3, -1 for the coefficients of x, and 4, -1 for the coefficients of y. We can then multiply this matrix by xy to give us the matrix -1, 2. So if we end up multiplying this row with this column, we end up with 3x take y is going to equal to -1, which is our first equation. And if we do the same thing with the second row and the column, we also get -2 here. So now we just have to solve for the matrix xy. And the way we can do that is by simply pre-multiplying both sides of our equation. Okay, we can pre-multiply both sides of our equation by the inverse of the 2 by 2. So 3, -1, 4, -1 inverse. So let us now work out what is the inverse of this matrix here. To work out the inverse of this matrix, we can simply say it is the same as 1 over the determinant of the matrix, and the determinant is going to be AD take BC. So 3 times -1 minus 4 times -1, and that is simply going to give us -3 plus 4, which is just 1. So 1 over 1 times by the matrix, you swap the values of A and D, so -1, 3, and then you change the sign of each of B and C, so 1, -4. And then we can times this by -1, 2. So now what we have on the right-hand side is this over here, and on the left-hand side, if we multiply the inverse of a matrix by the original matrix, or in other words, we pre-multiply a matrix with its inverse, we can simply say that this over here will equal to the identity matrix. Another way of saying the identity matrix is simply by saying times by 1. So what we end up with is this and this cancel, and we're just left with xy. Xy like such. So now all we have to do is to just solve this matrix over here. So 1 over 1 is simply just 1, so I'm not going to write that down. And we're going to now multiply these two matrices together. And if you don't know how to multiply two matrices, I do have another video which you can go watch. So this is going to be the same as we want to work out first the dimensions. So we know this is a 2 by 2, this is a 2 by 1. So the final matrix will also be a 2 by 1. So we want to work out the value in the first row, first column, first row, first column. So -1 times -1 is 1, 1 times 2 is 2, so you get 3. And then -4, we can do this times this, so then -4 times -1 plus 3 times 2, that'll give us 4 plus 6, which is 10. So there you go, xy is equal to 310. So what that means is that x is going to equal to 3, and y is going to equal to 10. Okay, this is our next question here. We have two simultaneous equations. Try solving them using matrices. Okay, so the first thing we do is we need to set up our matrix equation. So we have one 2 by 2 matrix which contains the coefficients of all our variables. In this case is -2, 4, 3, and 1. Multiply this matrix by xy, and we end up with the solution matrix, which is going to be 6, 1. So now what we can do to both sides of our equation is we can pre-multiply by the 2 by 2 matrix's inverse. So we can pre-multiply by the inverse and pre-multiply by the inverse. Okay, so let's start with the right-hand side. On the right-hand side, let's work out the inverse. So we do 1 over the determinant of the matrix, which in this case is 1 divided by -2 times 1, take 4 times 3. So this will give us 1 divided by -2 take 12, which is 1 over -14, or just -1 on 14. And then we can do this times by the AD take BC, we can swap around AD and change the signs of B and C. So this will get us 1 and -2, then -4 and -3. 6, 1. On the left-hand side, we have that these two matrices times to each other will simply give us the identity matrix. In other words, they just cancel each other out. So we can say that xy is going to be equal to this equation here. So now we just have to evaluate the right-hand side. So we can keep the -1/14, and we can work out what do these two matrices multiplied to each other get. So we can do this times this to get 1 times 6 plus -4 times 1. That's just 6 take 4, or just 2. And then we can do the second row times by the column, so -3 times 6 plus -2 times 1. That'll give us -18 plus -2, which is the same as -20. Okay, and if we really wanted to, we can also just expand out the -1 on 14. That'll give us a 2 by 1 matrix that says -1 on 7 and 10 by 7. Okay, and that is the matrix xy. So that means that x is simply equal to -1/7 and y is equal to 10/7. Okay, this is example number 3. Pause the video and give it a go. Okay, so now we set up our matrix equation. -1, 2, -1, 4. Times it by xy. And that will give us the solution matrix, -1, 2. So now that we have that, we can do the same thing we did before. I'm going to just denote this matrix as B. Okay, so let this matrix be equal to B just so it's easier to write. So we can pre-multiply both sides by the inverse of B. Okay, and we can see that this matrix cancels out with this matrix to give us the xy solution matrix. So to give us xy. And on the right-hand side, we just need to work out what is the inverse of B. So the inverse of B in this case is simply going to be 1 over the determinant of B. So it'll be 1 over -1 times 4 minus 2 times -1. That'll give us 1 over -4 plus 2. That'll give us -1/2. And then we can times it by the matrix where we swap A and D and change the sign of B and C. So 4, -2, 1, and -1. Times this by -1, 2. And now we can multiply the 2 by 2 matrix with the 2 by 1 matrix. First row times by the column, that's 4 times -1 plus -2 times 2. That'll give us -4 minus 4, so that's -8. Then we can do second row times by the column, so 1 times -1 plus -1 times 2. That'll give us -1 take 2, or just -3. And this is the same thing if we expand the -1/2 as just 4 and 3 on 2. Okay, and that is our solution matrix over here. So that means that x is simply equal to 4 and y is simply equal to 3 over 2. And these are our solutions to these two simultaneous equations. Okay, our next question is this. We have two equations and you'd need to solve them using matrix algebra. So first thing we need to recognize is equation 1 isn't actually in the form we want it to be in. We want our equation to be in the form ax plus by equals to c. So all I'm going to do to equation number 1 is just rearrange it. So I'm going to say it's going to be the same as, in this case, 2x minus 3y, 2x minus 3y, and that is going to be equal to 7. Okay, so now that we have it like this, we can now create our matrix equation. So 2, -3, 3, and 1 times by xy is equal to 7 and 5. So now that we have this, we can pre-multiply both sides of the equation by the inverse of the 2 by 2 matrix. Pre-multiply by 2, -3, 3, 1. And on this side, we do the same thing. 2, -3, 3, 1. Inverse of that. We can see that the inverse and the original matrix will cancel, so we're just left with x and y. And then on the right-hand side, we can just work out the inverse of this matrix. So 1 over the determinant. So in this case, 1 divided by 2 times 1, take 3 times -3. That would be the same as 1 over 2 plus 9, or just 1 over 11. Times by, we can swap the positions of a and d, and then we can change the signs of these two numbers here. And then we times this by 7, 5. So now we have this. Let us now multiply the two matrices out. So row times column, that gives us 1 times 7 plus 3 times 5, which is 7 plus 15, which also just gives us 22. So 1 over 11 and 22. And then second row times by the column, that'll give us -3 times 7 plus 2 times 5. That'll give us -21 plus 10, which gives us -11. So now if we expand out the 1 over 11, we simply just get the matrix 2, -1. And that's our solution to this equation here. We get that x is simply equal to 2 and y is simply equal to -1. And that is how you solve simultaneous equations using matrices.